Yo, Penguin. Oh, oops. Sorry. Alright. Yeah, we left off yesterday, I think, with some issues with the writers. Basically, if we put this in perspective here, pipeline, so echo only one process should work, and then we have binding to one process should work, and also binding to pipeline should work. But pipeline without binding does not work. Oh, and of course we get like a million. Messages right now, so I'm gonna disable this. And we still get the trace writer. Oops. What the hell? We don't get anything now. What? Okay. Huh. I wonder if it's because we wrapped them in the trace writers. Let's do a little bit more here. So let's say when we also like do things here, send file, right? So send file is the only thing that happens here. Now I'm not sure how we can get more information here. I mean, it might be, this might not work here, but send file and flush is the only thing that's happening. Maybe we should say, okay, well, how many bytes do we have? You know what, things like end is also not really happening. I think, yeah, I think this just doesn't work. the way I'm trying to do it here. Because there's other things than the buffer that... Like having this as a rider itself and then wrapping another rider doesn't really work. I mean, not the way I'm doing it right now anyways. Well, how could you get it to work though? Because I was thinking like it should just be a matter of just sending these calls on through. But then these calls are kind of depending on the wrapped rider and not the rider underneath. So maybe we should use, you know, if we change this, for example, to right splat. Which needs what? Data splat, rider. Oh, right. You don't need that. And send file. I guess as well. Flush is like, do we drain? Also, the buffer doesn't make sense now. I don't know. Let's try backtracking to this. Right, now we get this one, which is like trying to get some writable slice greedy, but it can't because there's no buffer. Okay, well, what if we had a buffer here? Let's add like, let's add a buffer here. Okay. Okay, so now we have a buffer. And then so drain, send bytes through logic link, and a right belong center could not fit into buffer or during a flush operation. Buffer is consumed first, followed by each slice of data in order. Modifies end. Right. So what if we just say first we're going to write all buffered and we set this to 0. And then we write the rest. Okay. However, we're getting this send file thing. And flush. Which is supposed to call drain repeatedly. I mean, I think we can just have the default flush actually. Although, no. Well, okay. What we'll do is we will wrap flush, but then we also say default flush which we call drain. And then we don't even need that parent there. All right. What about rebase? I don't think we need to do anything with this, but ensures capacity more bytes can be buffered without rebasing. The most recent preserved bytes must remain buffered. Only column capacity bytes cannot fit. So do you have a default? I guess we can just do this default thing as well. Okay. There we go. Cool. So we get a whole bunch of messages telling us what's happening. And then we also actually get the output. Okay, cool. So now it's properly sending this through here. So it's just a matter of this being not properly set up here. Okay. Now, what do we expect from this? Only one process. Binding to one process. S equals that. Yes. And then double line, new line, because it's double echo. S2, same thing. And then the last thing we don't get. Because, yeah, and that's what we expected, I guess. Because that's the problem we had before. Okay, but now we actually get the things outputted. So that's good. Now let's check out stream, because here we also implement the writer interface over here. And we have kind of the same things going on here. So I'm gonna look at this. And this is calling drain on vtable as well. So what we'll do is we will do the same thing. We'll take destination, write all, self buffered, self end equals 0, return destination, and write all, or no, write splat, data splat. So this might be the only issue we had. What did we do for send file actually? Send file. We just called send file there, okay? But not through the vtable, but through the normal thing. All right, there we go. And the flush, we don't call vtable flush, we call destination default. No. Self default flush. There we go. So really we could, this is kind of like also just a you know, tracing operation here going on. So yeah. And then same thing here. This would be like self default rebase. All right, cool. Oh, we got some errors. Oh, I see. Let's just return this. Please work. Can it be this simple? Well, okay. Now we get even less stuff happening. Okay. Well, okay. It might be because we're sharing the buffer. Yeah. Okay. Memory leaks. Right. Yeah. Because we disabled the init. Invalid free. Oh. Okay. Still that didn't work. Okay. You know what? let's do this. Let's do self-writer flush. We get the buffered. We write it all to the destination. But now we can actually use, actually we have to do it before. We flush out everything in the writer. Then we set the destination. Then we get the whatever we have written there. We write it to the writer, which should now send it to the destination properly. And then we also flush again. Okay, but I don't think probably this is where the issue is, but that will be a little bit more robust at that point anyway. Okay, so now let's look at forward. And we will stream to writer, self-writer. Nope. Okay. Okay. Yeah, that's the same thing. Flush is just calling default flush on self. Same with rebase. We could try and get a trace writer here. Oh, that's right. Let's do it after we have the destination, I guess. Label. Okay. So there's that. And then it's like, if we have a destination, we actually want now to return the trace writer instead. Which is gonna wrap the destination writer. Okay. Oh yeah. We also need this. However, we only need if we actually have a destination. There we go. Okay. So now we get a little bit more information here. Yeah, so standard out pipe gets send file here, which goes into this one, which goes out. So it seems to go through, but we get way less than we did before. Oh, here we can actually see the echo itself as well. Echo binding the pipeline. This sends it to this one, which doesn't really receive anything, I guess. We send the file, but we don't see where it goes. So maybe after we send the file, we should also flush, but we should do that anyway. Like, it could be that at some point we're not flushing. Where did we connect directly? So this, why are you jumping like that? This pipeline connects to standard context. And then it should be like consume pipeline. We do the forward. That should just flush it, though. This is yeah. We're flushing our writer. Which does this, which does default flush. Yeah, okay. And then actually the drain should also flush the destination, I think. And you as well. This is weird, like I don't see any output. I guess what we could do is here we could write splat. And this will be I just need to see this first here. This drain, no, wait, yeah, drain. The splat thing here. The last element of data is repeated as necessary, so it's written splat number of times, which may be 0. The last, so basically this has to be 1, I think. Because if it's 0, then we don't write anything, right? It's repeated n number of times, but is it like now, is it the 1 extra time? I guess we'll find out. Okay, so there, now we get the bytes written from this splat, right? And then end is gonna be reduced by this number. And we should only continue if we're out of the buffer, if the buffer length is 0. Then we do this. We continue with writing this splat here. If it's not 0, we should return this. No, 0. We should return 0 because we didn't consume anything from this data here. But then once we got to the actual extra data here, we will get the written thing. Yeah, so basically let's do like written is usize equals 0. There we go. So it's a little bit more robust if something, if like this doesn't write out entirely. We should also have the same logic in the trace writer. So yo, discordianism. Yeah, it's probably gonna be that now in the Christmas time, since yeah, since yeah, that's how it's gonna be. All right, right splat. Yeah, so that's, we get the number of buffer written there and this negative equal buffer written. We write that splat, we return written, and we also do try parent wrapped flush as well. Okay, I think we unclogged the pipeline here. There we go. You love to see it. So, all the frustration yesterday boiled down to misunderstanding on how the riders worked and how you should implement a rider that wraps another rider. So, yeah. Now every scenario works here. Echo binding, which does like, let's change this to printf here so we don't get double. Binding to one process works here. Binding to pipeline works here. And pipeline without binding works as well. Awesome. Great. Now, let's check this one as well. Whoops. This one, yes. Okay. I was like, whoa, I see errors, but that's from the execution, so that's to be expected here. So, yeah. JQ fails for the first one, very good. We inspect the execution. Well, we bind the same thing as well, and we inspect the execution, execode 3. We got some standard error out here. Very good. And then we also have this binding here, which echoes hello into JQ dot. Which also then captures the exit code of this now. This exit successfully, so it tries to find... It basically, when you bind S here, and we look at the exit code, it's gonna result in the exit code of the pipeline that was like the first error here. So this is succeeded, so it doesn't use that one. It looks for now this one, which did fail, so... But if all of them succeeded, then the exit code of the entire pipeline is a success. But now it grabs this one, which failed, so that's 4 there. Okay, and then it also had some standard error output, which is the result of the whole pipeline. So this thing here didn't like went into standard out or anything. It went piped into JQ, which then outputted some standard error, which we get here. And then we also have standard out, standard error here. All right. Which we also show that standard out is empty, standard error is this. Okay, cool. And that's it. All right, now I'm just gonna do a sanity check. I wish I had, well, we actually have MVP. So we could look at MVP. Okay. Everything seems to be good here. Why do we get 00 here? What is that? Is that expected or? I don't think it's expected. It might have to do something with the evaluation of expressions. But why would it show there? We get true a couple of times. Well, yeah, that makes sense. Okay. N equals 5. That seems correct. We got the function call. Right. This is an example string. Gets interpolated here and printed out. So that looks good. We also bind to a process call here, which looks good as well. So, okay. Right. The only thing weird that I'm seeing, well, okay, let's look through these as well. So we got my integer AB, a plus b is 7, my integer is equal to 3, my float is 2.5, integer plus float 5.5, 1, 2, 3. We're looping through the items, and then we also get this here. Okay, cool. So that all works. The only thing that's weird is this part here, which we get 00 there. So let's run bash and see what we get. Okay, well, that one didn't get the 00, so it might have something to do with this binding here, but it also seems weird because it might be that this if is like an expression, right? And we get like the exit code. Maybe. I'm gonna inspect this. It's an execution. Now we don't get the double thing there. So it might be because of that. Yeah. We also see double true. Oh, because now we're binding it away, right? Okay. Let's actually go, let's look at this. Because this is like evaluate if expression. So we evaluate the expression, and it could, if it's a block. Oh, but we actually return a void as well. So no, we don't. We return the result, right? So if it's a block, we evaluate the block, and in the end, the block always returns void, right? Which will change, actually. But yeah, that makes it so that we don't show anything. However, if, for example, it's a process call, we return run function instead, which returns the function, the value of the function body. And basically that's gonna evaluate into this thing, which returns the process ID. And then we go back to execute expression, which will process that. And if it's a process, we will get an exec code, which then will turn into the number 0 and be output to the screen. However, I don't want it to be outputted to the screen. That's the thing. So when we materialize this as a string, we get that, but actually it kind of depends on the context now. We don't really want the exec code to be here. That's the thing. Like, yeah, if we are in execute expression, like I'm not sure, like, because this all stems from the fact that hello world actually it can be written like this right now, but I don't know. Maybe we should just not do that. Because it's like it's kind of like we're auto printing out whatever expression we get, but it leads to all kind of problems that you get all these prints that you didn't mean to get. But it would be cool though if we could make this work better. Yeah, maybe we should just not do that. I don't know. Yeah, okay. Let's change this. There we go. And the only thing we really need to do is we don't make this into a string. What app am I using to code? This text editor is called NeoVim, or code editor. Oh yeah, we're doing this stuff. No, let's... Yeah, I guess... It was fun while it lasted. I don't know. It becomes too weird if you just do this. Or if you have, like, you know, a string, you say it's the string, it will output it. It's kind of cool, but I don't know. It becomes too weird with all, like, it becomes too convoluted on to understanding, okay, what will actually be outputted on the screen, I guess. Alright, so what we want to do now is probably, well, okay, I think the pipelines are restored. So this streaming thing, what else are we looking at to make this work here? I'm not sure. We're not gonna do the block thing. We're not gonna stream a block or a function at this point. So functions are not able to be like piped to, which is sad, but that's just how it's gonna be for now until we can get that working. Can you code HTML files in there? Yes. You can basically code any language that you want, I guess. I mean, as long as it has the necessary tools that you could use. But I think most languages are probably you can use this for. All right, which is to say that I think we're good on the streaming now, for now. So fixed streaming writers. Now, I was actually tinkering around before with making an IR, because I was thinking that, hey, maybe we want to be able to debug Runic. I mean, yeah. And then I was like, okay, well, how should that happen? And I was thinking about like expression, not really expression walking maybe, but like some kind of generator function that would, you know, you could pull the next execution unit out and execute that, and then inspect whatever what the context is right now. And I was like, well, maybe it's easier if we first turn it into like an IR, which is more of a kind of like a list of instructions instead of a tree like the AST is right now. And that would probably be easier to keep track of the context when you have a list of instructions that you just jump through instead of a tree, which is gonna be maybe hard to keep track of where you are. And I don't know, maybe you can do it, maybe it's easier than I think about, but it was kind of cool. If we get an IR in the language, it would also be closer to kind of trying to make a compiled language as well, to make the scripts more performant as well. Like right now you could clearly see the difference here. So if I run MVP, you can see it takes some time. If we time it, it takes like, yeah, I don't know, 1 second. Felt like it took more. And then we do bash MVP, which is exactly the same code. It takes like 1/10 of the time. So it's not very fast right now. But again, that's not the real goal. But it would be cool if we could get an IR because of several reasons. Like, as I said, we could make it more closer to a compiled language, which could make that step easier in the future. Maybe easier to debug as well, like building a debugger. And maybe a better evaluator as it is right now, like evaluating the expression tree. I mean, it kind of works, but it also feels like we're making a lot of leaps sometimes. I don't know, but also but when I started the IR, it's also like, okay, well, how do we deal with like the pipelines and stuff? So it's not like just do it, but I'm basically doing it a little bit in the background just because I'm like experimenting a little bit. So I don't know, it's not something that I might want to show perhaps on stream right now. Maybe when it's like when I have a better idea of how it should work. Oh yeah, I haven't merged this yet, so let me just do that real quick. There we go. Okay. Cool. So now what? Well, I was thinking of maybe getting either getting the types checker up to date, so I don't have to skip the type check every time. Maybe that. Also doing like implementing more things in here. So that's what I'm thinking. Expressions as pipeline stages. What did I mean by that? Stages. Exit code and execution. So this one we do have now, which is nice. When binding to a pipeline running gangs. Okay, that's fixed. Figure out what to do with standard error. That's kind of fixed, yeah. Okay, because we are doing that and it's all like synced up and everything. So yeah, the only thing we don't have is basically if you bind to, let's say you bind to here, you bind to this. We don't have a way to extract the combined standard out standard error of this right now. It will combine if you just call this without binding, but when calling like this and binding, we like extract standard out standard error in two different things right now. So we could make another, you know, combined output as well, but yeah, whatever. LSP, I don't care right now. Standard lib, parser. Yeah, this one is still in progress here. Type expression, type checker. So we could try to get the type checker out in shape. Let's just do this. Let's go to MVP, because this has basically almost every feature up until this point that is currently working. And we can now run mvp.errorrn. So this now we see like, okay, we get a type checker fail here, and we enable the type checker logs, which now we can see exactly where things go haywire. So line 2, first expression. So we get unsupported expression, right? Okay, so it's a call. Okay, so the call is unsupported, right? So let's go over to our type checker, and we will. Actually, you know what? I'm gonna delete the semantic AI, because that's like I'm not using that. Also, we have like, there's something like modules somewhere. Not sure where that is. Module parser deprecated. I'm gonna remove that as well. There we go. Very nice. Let's do a build so we don't. Wait. Where is this front-end parser? Why do you have this? It's not even used. Okay, there we go. Type checker, that's right. There we go. I'm just gonna push this here, deleted. Yeah. Remove some duplicated AI slop. Okay. So. Run expression. We have the call, which is unsupported, but the call is basically, well, okay, well, yeah, let's just do it. Yeah. Run call. Oops. Okay. Oops. So the call has a bunch of arguments, and the callee. Yeah, I guess we'll go through these. So this is basically just gonna be run expression. Scope. Expression is callee. And then we just loop through the arguments. And we just run that as well. Okay. Do we have anything else we need to worry about? No, don't think so. Alright. So that's that. Now we should have that. Okay, we got a whole bunch of errors here. Cool. Echo not declared. Okay. Fair enough. I had a idea of actually making maybe this is where this comes in actually. Because the echo, identify echo not declared. It kind of makes sense to have to declare it. Like all things, because right now how it works is basically everything that is not declared is kind of always seen as some kind of we're trying to execute some kind of executable, right? Which makes sense in a shell. You're trying to execute an executable. You just type the name of the executable or whatever alias or function or whatever you have in the scope. But for a script, it could make sense to actually define whatever executables you're gonna have available, because then the semantic check will be a lot better and you're gonna catch typos, you're gonna catch all kinds of errors like type errors and all that stuff. So what I'm thinking is we have executables, something like this. So this kind of syntax I've been playing around with, like so this one, for example, is the idea of having a reference operator, which will change the thing on the right hand side to be a reference of the thing instead. So and this bang echo here will be, the calling explicitly the executable echo, which I argue that either you could. Okay, so basically what this expression will do, if I just finish that explanation first, is going to be a reference to the executable echo instead of executing the executable echo. However, I'm thinking if we want to have it because then the idea would be that you could still type this or something else, cat into echo or whatever. or cat or whatever, you know. But this would still have the same issue that we're trying to fix. Like, yeah, you just put a bang, you can put anything in here. But it won't catch issues like typos and stuff here. So maybe either you can shorthand it like this, you know, something like that, like defining that, okay, well, I want to have echo available, cat available, whatever, and that will, it won't be good maybe for like short scripts, but for larger scripts it could be good to have this. I'm not sure, I'm a little bit on the fence, but the semantic checks would be a lot easier though. However, we could just, you know, we could just say that, okay, well, if we don't see the identifier, let's just assume it's an executable. So then, or, you know, some kind of, you know, we treat it as the type of what an executable is. So, but yeah, I was just playing around with this idea, and yeah, so that's what I was thinking there. Because we could still just do this and treat everything that is not defined as an executable, and I could still work with the type system, everything. It's just that if you do this, we can't really see if there's an issue with this, unless you want to have some analysis of the current environment during compilation, or not compilation, but during the type check, the semantic check, and see that, hey, we don't have a thing called CA. Are you sure this is correct? You know, I don't know. Maybe we could have like a dry run, which would go through and check that every executable that you're trying to execute at some point actually exists in the environment. That we could have. Yeah. Okay, well, I think what we're gonna do is we are going to not have that special syntax. We are just going to assume that everything that does not exist will be trying to be an executable that you're trying to execute. So when we run the expression, and we run, for example, an identifier, and we look up and it doesn't exist, we don't get an error. What we get should be instead, well, it's not found, but we don't really care unless we're trying to get some type out. So actually, well, if it's not, okay, so run assignment, if it's not found, return. Well, that's not really true now, okay. So if it's not found here, it's going to be the, hang on, what are we trying to do here? So this resolves expression type on assignment expression, assignment identifier. Oh, if the identifier that you're trying to assign to is not found, okay, then okay, that makes sense. That makes a lot of sense. Okay, but the type, if we're trying to resolve a type expression, and then the identifier, where is that happening? Man, there's so much happening in here. Oh yeah, we just call result type on the thing. So if we go to AST, we go to identifier and resolve type, we look up, we get null back. So if we get null back, we should like, it should be like the default type expression that is for executables. Which we actually could define here, like as a global thing. It's going to be a function with variadic number of parameters that are all strings. It's going to be returning a stream of strings. It's going to accept a stream of strings of standard in. Although that's not defined here. The standard in is not defined here. That's weird. We should have a standard in type here. Okay. Type expression. Alright. So let's do like executable type. Well, it's actually this. So this is going to be a type expression, and it's going to be a function. Return type. Now we don't have like stream of strings, so as a type, I'm just gonna say string, perhaps, or actually no, the return type is kind of like an execution result actually, which we also don't really have as a type right now. But it's more like a struct, but whatever. Let's just add this execution. Oops. Where did you go? All right. Let's see. So yeah, because these are like always. I mean, we don't actually. Well, we don't really need this one to be a type expression. Maybe we do. Actually, yeah. Yeah, because these are always like pointers, so we have to kind of create it, unfortunately, here. And then we have to also create the return type. Oh no, actually, no, we don't. What the hell? We could just do that constant as well. Yeah. So we'll just have like, I'm just gonna make this here. So this would be the executable return type. It's gonna be a type expression, and this is, I mean, it's gonna be like a stream of strings, but we don't, as I said, we don't really have that type. No, what am I saying? It's an execution. Yeah. I mean, it's kind of weird. It's kind of both, really. It depends on which context. Like if you're in a pipeline, it's weird, and then the result of an execution, like the result of a pipeline is an execution. The result of a process call is also an execution. However, if you put a process call inside of a pipeline, it won't be an execution. It will be like, you know, the whole pipeline is one kind of expression. Which I try to kind of make it work with having like each stage of the pipeline be one unit of thing that you could then pipe stuff into. But I mean, that could still work and would probably will go that way, but I couldn't fix it at the time to be whatever we needed it to be. So execution, oh yeah, you need a span, that's right. Oh, okay, I'm just gonna say this is global, whatever. So execution is something that has a span. There we go. And that's our executable return type. So now we can do the address of that. So there we go. And then we have standard in type, which actually we don't really have. So I'm just gonna do this to do implement. Okay, what else do we have? Function. We have parameters and span. That's right. So span is going to be global. Parameters will be something. Oh yeah, it's dot variadic. That's right. And it's a variadic. I think it just has to be like strings, a string here. So executable parameter type. It's gonna be a string. Oh yeah, and a string is just an array of bytes. That's right. Which also requires its own thing. So executable parameter type, executable, so global string type. Let's just do global string type, global byte type. It's going to be a byte with a global span. There we go. Global string type is, with the element is global byte type with span global. And then the parameter type is going to be the global string type. And now you are executable parameter type. Okay, I think that's it. Okay, so now we should be able to say, oh, right. that. Okay, now we have all kinds of stuff going on. But basically we're looking for the identifier. No, it is t. Result type. And if this is null, we are going to return the type expression dot, or just, I think we could just say dot actually. Executable type. I think. No, maybe not. I thought we could. Isn't this the... No, maybe not. Oh, it was part of something else. Here it is. Now we should be able to do that. No? Really? Okay. Run member. Right. Oh yeah, so an execution, actually, yeah, so execution does have member access. So we need to do like execution and run execution member access. That's primitive, right? All right, because it always has the same things. So no. So basically, if identifier name is equal to exit code. So this is kind of like we're probably gonna replace this with a struct later on, but we don't have structs right now, so I'm just gonna hard code this in here. So if we're trying to have the exit code here, we are going to return a type. Or wait, no, we're not trying to return a type. I guess we're just trying to see that this is possible to do, I guess. Yeah. So this would just be not an error, I guess. So if it's exit code, if it's let's just do like valid members. It's going to be a list of strings. Well, okay, this is a constant list of strings. There we go. So we got exit code, we've got standard out and standard error. we will loop through these and then check if member is equal to identifier name, or yeah, if it's equal, then we can return. If we get down here, that means we didn't find any valid members, so this would be an error now. Member not found. Wait. Oh. Okay, so now we got validate type assignment. So this is now a execution validate type assignment execution. Right, it's basically the same thing, except here we check execution instead. All right. Hey, now it works. Okay, cool. I thought also that like the member access expression resolve type needs to be implemented as well. Yo, board checker, what's up? Oh, so this isn't even a thing? Oh wait, I don't think this is used anymore. I think it's like a binary expression now. Yeah, it's a binary. And okay, we don't have anything here. Okay. Yeah. All right, cool. Well, at least now we don't have to say skip type check for every little script. So there we go. Let's bring this in here. Fixed so that we don't have, well, type checker. So basically, I mean, we fix the current, well, yeah, I'm okay. Fix so that you don't have to skip type check. We can't say anything about it being like up to date or anything because there's a lot of things still missing. I'm just gonna say that, hey, you don't have to skip the type check now every time. Okay. Cool. Now what? Should we just continue with implementing more features here? So we got a bunch of stuff. We got like assignment modifiers, string concatenation with plus signs, which I might ban. I got LSP working. Ah, nice. Pre-sema version. What does that mean? Semantic. Okay. Cool. Awesome. It means LSP parts before semantic analysis is made. Yeah. It has some missing stuff, right? Yeah, that's same here, man. There's a lot of missing stuff. But yeah, that's really cool. Yeah, it's really cool when you get it and it's like connected to the editor and you can see everything like working. It's a foundation. Yeah, nice. So I mean, these are basically feels like a lot of these are just things. I mean, let's just go for the top down here. Let's do the assignment modifiers. And it will basically be like a binary expression. So let's go to our dear old AST. Actually, we should start at tokens for this, because I don't think we have like plus equals in the Lexer right now. Well, okay. Operators. So many ideas. Promises. Optionals. Error types. All kinds of stupid shit there. Pipe. Yeah, these are stage separated. What does bang do for pipelines? I guess that's like not. Okay. Also pipe and or, kind of the same thing but different. Yeah, we got all kinds of things in here. Colon, comma, dot. Where's like plus and minus and stuff? Here. All right. So let's do plus equals plus assign minus assign star assign slash assign. I'm not sure why it would be called star assign. It's clearly like multiplication. We could have mod assign as well, I guess. But yeah, it's really cool when you feel like it's like working. You get the diagnostics in, you get... Well, what language are you making the LSP in, by the way? Would it be less writing to call than sim as in plus equals star star? Probably. I'm just putting things in here, and I will like refactor it later. To keyword, no, keyword map. Mod assigned to rem assigned, no. Why? It's not equal true mod. I mean, it depends on how you implement it, I guess. But yeah, I mean, to me it's kind of the same thing, but I mean, yeah, usually I think the percentage sign works only with like integers, so there you can call it remainder, I guess. But I always see it as, you know, modulus, and I don't know. I don't really use modulus, I mean, fine, sure, whatever. You convince me. All right, so let's see, lex minus. What the hell? What is happening here? Like advance. If we match. Oh, I see. Then we got that. Okay, yeah. So all of these. I'm gonna try. Like I'm probably gonna like make my own Lexer. This is all AI slop here. This is all AI slop. Like, to me, this is way too procedural. I don't know, but yeah. Anyway, okay. This is going to be Lex plus. Yeah, that's true, but it's like I feel it when I need to extend it and do all this crap here. I basically want to change this to be more configuration based and not, you know, like this. So this will be equal, then it's going to be a plus a sign. Otherwise, be plus. Star. Div or slash. What is it? Percentage or wait? What is it called actually? Percent. AI works well only if user knows what they want, how they want, why they want, and how to want. Yeah, that's the thing. Like many people, they view AI as kind of this magic box that you can just, hey, do this, and it will be like a perfect result. But that's like, yeah. And then you quickly learn that, hey, that's not the case. You have to like think about everything, and then you can basically do it yourself by that point. But I mean, it's good at certain tasks. It's good at the boilerplate stuff. If you can direct it to do, hey, follow this pattern and apply it like everywhere here, that's really good. Why not use a keyword map and a symbol map from longest shortest? Yeah, so I mean, you're just saying like, yeah, I'm currently extending the AI slop right now, right? And I said before that I'm gonna probably redo this with using some kind of configuration based instead of this. But I won't do it right now because I'm just extending these small things right now. No, slash. Yeah, so what I could do is make the blueprint and then ask AI, hey, can you extend this to match the other one that we had previously? That would be a good thing for AI to do. But I would have to work out a little bit more how the blueprint will work, but yeah. That could be it for like an easy like migration to another kind of thing. But yeah, I will just put it here, and for now. All right, there we go. Now we have those tokens. Cool. And now we need to go to AST. Same thing goes for the AST. AST is also a bunch of AI slop. Where's the binary? It's just a binary. Binary operation. Let's just do it here. Like, well, we have a sign down here. Let's add it to this, I guess. Add a sign. Minus a sign. Multiplication a sign. Div a sign. And a sign. So are they all 0 here? A sign is, I'm pretty sure, should be 0. I mean, they should have the same. They are all assign type things. It doesn't really make sense to mix a bunch of those, you know. But yeah. There we go. So now we have this. Okay, now we get to this part. Oh my god, okay. Yeah. This is like the dreaded place because we have so many copies here. And I tried to generalize it first, but it was like, okay, well, it's because these operations and the types and the conditions, like everything is different, but still the same, kind of the same. It's just gonna be a nightmare, this part. I need to figure this out at some point. All right, so now for assign, I'm gonna look at evaluate assignment, and okay, so what we'll do is we will first calculate the results, which is going to be some kind of value. Actually, let's make it like novel. Result equals to that. You know what? Wait. No. Yeah. What we'll do? No, this isn't. This isn't an operator. This is just. We could just make it into a binary expression. Like we could just expand it to a binary tree. Right? We could just expand it to whatever AST equivalent it was going to be. We don't need to have a special evaluator for this. It's basically a combination of assignment and add. I think. So, in our parser, we also need to have support for it in the parser as well, of course. So let's go to parse binary expression. And of course the thing over here, is where we also add these things. These are things that are valid binary operations, which should also be a different kind of way of doing it, but hey, this is where we are right now. I'm just adding these things here. Multiply, assign, div assign, and div assign. Okay, now we got those in there, so now we should get things. So parse binary expression. It's kind of weird now because this kind of it's going to like expand the binary expression. I mean, I guess that's fine. So we have like left operation right. Now we do have a special case. Wait, where's the special case for like assign? Because if you assign, the left hand side has to be I guess it doesn't have to be an identifier. It could be an expression. No, because we don't have references right now. Although it could be like a member access. So if we say like, you know, const s equals hello, and then we say s equal, well, let's do bar x something else. That's all good. But then we say like hello equals hello. Where will this fail? This will be an execution error. We should like, it should, I mean, it should really be a type error, but we don't have, wait. This is not a type error because the type of this is a string and this is a string. If we had 5 equals hello, this would be a type error. I think, or not? No, you're not. No. Okay, well. Because what I wanted to do is basically, if we do this, we have to turn this into expression. So this will be turned into, you know, hello equals hello plus hello. That's what I want to do. So we basically just need to say here, but then how do we deal with like duplications? Because if this is some kind of super strange expression here, now that would just be put over here. This is like the right hand side, and this is the left hand side. It's the left hand side that's gonna get duplicated basically. It doesn't matter because those are constants as well. Yeah. But if something weird, some side effect is happening on the left hand side, that's gonna be the issue. Because it gets like duplicated. So we can't do this, I don't think. Because this could be some kind of function call that returns a reference or something that we add to, and then that's gonna be bad. So now, okay, we actually need to handle these separately. Okay. Well, okay. But what I was going for actually was first adding, get the result. Store it on the left hand side. But then the left hand side has to be like some kind of reference. That's the thing. Right, that's the condition there. If the operator is assignment then the left hand side needs to be a reference. So that's going to be either like an identifier or a member access. I'm just gonna see if we can have this function here. Is reference now there might be, you know, the referencing that might be like a semantic check later to get like the type, the actual type out, but for now it's just going to be like identifier. Member access is like the two kind of reference things we have right now. Actually, member access is a binary now, so we have to check. Hey, yo, 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 yo. No field named add a sign. Now it's plus a sign. Okay. Inconsistencies. Whatever. Okay, well, parse, no, init binary. So now we're checking like, okay, well, are we trying to assign something? Okay, let's check if the left-hand side is a reference type. In that case, well, if it's not a reference type, then expected reference after, no, expected reference before assignment All right. There we go. Which kind of does make it so that we can actually duplicate the left-hand side now, but what I was thinking here is maybe for add a sign, we would make an add expression first. Now this only works for identifiers right now. Right, assignments. Oh, okay. So assignments only work for identifiers. That's actually not that flexible. It should also work for like member access, but I mean, I guess we don't really have that right now though, but for binary expressions it's going to be different now. Wait, but do we have a sign here now? I think we kinda do, maybe, I think. Yeah, here we got a sign. Here we're checking, like, if it's not an identifier, then it can't be assigned to, right? So for now, we could actually just use we could create an assignment operation. So we could do result is going to be equal to well, let's do like binary expression no. Left is binary left, right is binary right, and operation is add. We can also generalize this later, but let's do that. And then span is whatever binary span. Okay, so now we can do evaluate self, evaluate binary. Oh yeah, which makes it so that this could actually just be a binary expression. Actually. So this would be our binary here. Oops. And then we get a value out. And then we would simply say there's no sign here. I think we have to kind of look up to get a ref out. No, we just do this, and then we do evaluate the other binary. Which is going to be a sign. But then this is an expression, so that doesn't work. We evaluate the expression first. We get the binding. We will. I mean, we could extract this part into another function, which is like assign. I just learned this, by the way, which I probably will have a lot use for. If you select something and you're like, hey, I've messed up, and you pressed this, like you pressed escape to get out or whatever, now you lost it. So before I always did it manually to go back, but I recently learned you can press GV and you get back. That's incredible, because I do that all the time. Like, that's gonna be such a nice thing to put into the workflow. All right, so we deinitialize previous variable. Good. We don't need to evaluate an expression. We just put the value in there. And there we go. And now I can say assign binary left identifier name value. Okay, and we'll do the same here. Try self assign scopes binary left identifier name value is going to be result, and then return results dot clone, because we need to like store it and all that. So there we go. All right, so what we can do now to like generalize this is that we could add all these things. Okay, all these different assign things, and then we can say, instead of doing dot add here, we can say, because we have the operator, binary operator, we can say to like unwrap assign, something like this, you know. And we will go to here, we go to binary operator, and we'll add this function here, unwrap assign, which will give us another operator, and we'll return switch on self, and we will do add assign goes to add. We'll basically map these to their counterparts. Goes to minus. Is it minus? It's called minus? No, subtract. y goes to multiply div goes to div. Else we're gonna do compiler error, or wait, let's just do some kind of panic. Okay. There we go. Now those should be a little bit generic now. Operators unwrapped here. We still have left, right. We evaluate the binary of that expression. So there we go. Cool. So I guess now we have those. So let's try it out. Now we still have like string concatenation, so we could do this. All right. Shouldn't happen. Oh, from token. Okay. Yeah. Okay. From token. Yeah, from token. Plus assign. Expected reference before assignment operation. Okay. Yo, Blue. What's up? His assignment. It's not a reference. It should be an identifier, so I'm not sure what's going on here. And this should be the whole binary span as well, or span. Actually, it's just the left one. Actually, it's the left span. Expected reference before assignment. If it's assignment and left is not reference, which means it's not an identifier, right? Because this returns true. So what the hell? Actual is what? Call? Oh. Yeah. Okay. Yeah. Right. Okay. So, right. Here we go. Okay. Instead of checking assign, we're gonna have to check is. Assignment. There we go. Cool. That works. And that shouldn't work. Unsupported binary, yeah. And then we have like, you know, x equals 4 point something, y inspect x plus y. That was close to 7 there. Times. No, but that this doesn't check anything. Let's do like x times equals y. Okay. And then the y is equals y. Okay. This is a, I think this is a parser error. Because we don't get the error. Unexpected token. So what do we have? Div assign. Oh, I never put this in because it was a part of this part here, so I missed it. Okay, there we go. See, that wouldn't have happened if I went for more, if we had a more config based thing. Okay, cool. But I mean, whatever. It wasn't that big of a deal. Yeah. Let's do like I don't know, x mod 2. It's not the remainder. I mean, I wasn't expecting that, but yeah. I think it's okay. Let's check the evaluator. And we have like remainder. So it's actually not remainder, it's mod. What about, like, should we implement it fully? Like, is it supposed to be the remainder? I think JavaScript, if you want anything good to look at, yeah, that does the same thing. But I mean, What about bash? Bad question, because bash doesn't have floating points. What about basic calculator or whatever it's called? Okay, that does the same thing. So hey, I mean, I guess it is the remainder. I guess it's still the remainder. It's just not integer. I don't know what the formal definition is. Whatever. Anyway, it works. Cool. Let's add this to like let's add it to the MVP. Assignment. What is this called? Combinators. What are those operators called? Compound assignment operators, augmented assignment. Okay. Wait, it felt like we had another one. Oh yeah, minus. Okay. So that's that. Also, if you have spaces, it like messes things up as well. That's also something I don't really like. Okay, I'm not. Okay, I have to stop that. Now, pretty sure bash doesn't have this, but I'm just gonna look this up for now. Bash add assignment operator. Because like arithmetic stuff is very special. . Okay, here we go. Class equal. In the context where an assignment statement is assigning a value to a shell variable or array index, the plus equals operator appends or adds to the add variable's previous value. This includes arguments such as declare. Okay. So it does work, probably. Maybe. Okay, well, we'll try it. Although this won't work because we don't have floats, I guess. Also, what's going on here? So that should apparently exist. Shell allows arithmetic expressions to be evaluated as one of the shell expansions or by using the double parentheses compound command. Let declare built-ins, the arithmetic command, arithmetic for command, the double brackets conditional command, or the I option to the declare built-in. Evaluation is done a large is fixed with integers available with no check for overflow. Blah 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 blah. I was just trying to find like an answer real quick here, but I guess we'll check this out a little bit. Shell variables are allowed as operands. Parameter expansions performed before expansions written. Within an expression, shell variables may also be referenced by name. So I wish there was like examples here. Because they're just listing a bunch of operators. Okay, well, how would you use this? Because it doesn't seem like it works. Okay, anyway. Always have examples. Yeah, it doesn't even, okay. Command not found. So do I have to do this? Or what? Parameter expansion syntax without using the parameter. Variables may be referenced by name without using. Because X, where X is a shell variable, okay. But what about assigning? Okay. Yeah, look. So this should apparently work. But syntax error, invalid arithmetic operator. It's like it's expanding the my var float. Is it because I'm not doing this or this or Oh yeah, there was no floats in here. Oh yeah, okay. Sorry. You have to, I have to use, well, I can do this. Oh yeah, there's no floats. Okay, that's kind of unfair then, maybe. I don't know. To use floats. Let's change, I guess we'll change it. Don't have rename. We could change it to like man, the rename thing is gonna be incredibly. You're gonna have to keep like references and everything in some sort of table or something. Okay, let's just do integers, I guess. One sec. Alright. Let's just do this to make it a little bit fair, I guess, since they don't have floats. We could use like basic calculator, but I'm not sure, like plus equals doesn't really make sense, I guess, for that. But yeah. So this is 1. This is plus 3 minus 1 times 4 divided by 2 mod 2. Okay, there we go. So there we can see all of those things happening in here. So we start with 1, we add 3, we got 4, subtract 1, we got 3, times 4, 12, divide 2, 6, mod 2, 0. Okay. And here's the slow as runic thing. And we get the same. Okay, cool. So we got it in here, which means we could test it. It kind of treat this as kind of like a testing suite as well to check what things work and what things are not working. Right. Okay, so that's that. Add a compound assignment. Okay. All right, and we could also add, you know, that there's, you know, we could add more assignment modifiers. I don't know what it would be, like some this, but this doesn't really make sense. I guess if we had an execution result, we could kind of do it. If there was an error in the execution result, this would become the right hand side. Now if there was an error, this would be the left hand side. Yeah, I guess that makes sense. Yeah. And then What else is there? Like they had like bit shift, but I'm not sure. Like, is that really necessary for this? Okay, so there's like, you know, there's plus plus, minus minus. I've never been a fan of those. Pre plus plus, I guess we could add it, but I'd nah. We've got not and negate, like bitwise negation. We've got exponentiation. Okay, that could actually be. More binary operators. Exponentiation. Bit shifts. Is that really necessary for a script? Like, what kind of bit shifting are you gonna do in a bash script? I mean, I guess we could add it. It is in Zig, I believe, as well. So whatever. Let's just bit shift left. Remember, plus placed. Yeah. I know about that. I mean, I was self-taught in C++. No, yeah, I know, but what the hell? I've never liked those. And like the plus plus before, it's like it's only used in very, very specific situations. So it's like it's something you basically never use. It's like in these old school for loops where you go like reverse or something. It could be used in some niche situation. I don't think Zig actually has plus plus, but it's like, do we add it just because Bash has it? We don't really need it. That's the thing. It's like you would mostly use it in like for loops, but since the for loops you use ranges instead and you operate over an array of things, you don't really need the plus plus minus minus. So yeah, I'm just gonna skip it. Okay, then we got like bit operators. Like, okay, if we're gonna add bit shift, I guess we'll add the bit operators. No. Because and will become another operator, which is the background operator for, you know, background processes. So I guess it depends on the context. Yeah, it could. It falls down to semantics, I guess. Zig plus plus. Well, is there a plus plus in Zig? What? I didn't know that. How is it binary? Can you add? What the hell is this cursed thing? Oh, it's array. Oh my, okay. Yeah, I knew about the array. Well, D increment is unary. But there's no minus minus, right? This doesn't exist. Yeah, okay. You scared me for a second there. Yeah, we're not gonna have plus plus either in or where it's probably gonna be plus actually. Like array concatenation is probably gonna be plus. Because plus plus is very specific. It's only compt time as well. Compt time. This is XOR, right? But this is not a binary, though. This is a unary. Ternaries. Probably don't need ternaries. You could do, like for ternary, you could do condition and then or else. That's a ternary right there. Right? I mean, it's kind of ternary. It's, well, it's not really a ternary, I guess. Well, it kind of, I guess it depends. Like if this is an execution result, we're looking at the exit code. If it's a boolean, it's this is just a boolean expression. However, it could also be like this is a boolean. Then we run this expression basically. So so this could be a pipeline here which fails, and then we do the fail safe here. Yeah, I guess bash ternary. But apparently there is ternary in bash. We can do that. Plus plus use general. We place increment depending on placement else. Mixing zig-like and bash is a priori a bad idea, but that's what we're doing. Or do you mean like that we don't ever treat this as? No, I think what we're doing here is with these operators only work on exit codes basically, and this is the Boolean style. So we're gonna have both here. But it's gonna be confusing. I'm not sure actually. Like this is good to keep the old style as well as, well, they are different though. They are different like operators. But again, it's so common to use this in programming languages as well for Boolean operations. But it's also used for truthy values and falsy values as well in, like, you know, dynamic typed languages. So there's a lot of, I guess, confusion about these operators as well. And if we add two kinds. I'm not sure if that's good or bad. But they will be separate. They will be separate operators on separate things. You will get type errors saying that, hey, you need this to be a boolean, and these need to be, well, actually this need, well, if you have an or here, then these actually need to be booleans as well. But this has to be a boolean, and I mean this can also, this has to be a boolean as well. But in dynamic type languages, it's like this is truthy, then the whole expression becomes this. If this is falsy, then the whole expression becomes this. If both of them are truthy, no, wait. If this is truthy and this is, then this becomes the expression. If this is falsy, this becomes the expression, and so on. Yeah. Yeah. I don't know, man. We'll see how it goes. I don't think the bitwise operators are gonna have specifically high priority. I mean, it's super easy to add because it already exists, of course. But I guess exponentiation would be like the most useful here. Maybe, I don't know. I'm probably gonna put this off indefinitely. This could be really cool though, because this could allow you to do something like, I want some kind of execution here, you know, some kind of pipeline going on. And then you want some kind of generic, like, okay, well, if things did go wrong, if things did go correct, if things failed, well, either you can have an or at the end, or you can do afterwards. You can have or equals and then a and then you know, handle error, something like this. Well, actually, if it's equals, I was thinking like the monadic style, like, okay, well, if something goes wrong, it's gonna be the handle error part. No, wait, because we're setting it to equals, basically gonna be this then. Yeah, it could be like a fallback handle error thing. Fallback. Yeah, this is more like a fallback thing. And you know, at the end, this would be handle error. However, then you don't have like a fallback. But you do this, if you errors, we have a fallback. Use pipe greater than. Is that a bash thing? Because this makes sense to me, because the ordinary operator for the or, if something fails, is this. And you could use this as an extension of that to mean, hey, if this failed, we assign it to fallback. So that makes a lot of sense to me, considering the bash syntax. I'm not sure if it exists in bash though. And that operator that you gave there, where is that? What the hell is this? I just read a thing in the bash manual. Look at this. Control operator, a token that performs a control function. It is a new line that, like, yeah, stands for like one command or whatever. And then one of the following, or and background process, multiple commands. This, I have no idea what this is. I have no idea what this is or this. I mean, yeah, that's just pipe. I don't know what this is. Maybe pipe and background at the same time, or parentheses. Okay. Pipeline. If this is a pipeline, standard error indentation, standard output is connected to standard input through the pipe. It is shorthand for 2 and 1. Wait. One standard error in addition to standard is connected to. Oh, I see. Okay. Well, that I did not understand that from the operator. Okay. Okay. So it's a short. It's like a redirection shorthand thing. Okay. Cool. What about this? Case. Okay, so that's for cases. See? Just reading this blows my mind about the syntax here. Like all the different... Each clause must be terminated with semicolon, 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 and, or semicolon, semicolon, and. So... The first pattern that matches determines the command is executed. This command is. But what is the difference between? If this is used, completes after fast match using this in place of this. So using semicolon and causes execution to continue with the command list associated with next clause, if any. So is that like a fall through or what? Cause execution to continue with the command list associated with next. Okay. Semicolon, semicolon, and ampersand, I guess you should say, in place of this. Causes the shell to test the patterns in the next clause if any, and execute any associated command list if it might succeed. Oh, interesting. Wow, I've never seen that. Thank you, piano. Same to you. Return time to 0 is no. Okay, cool. So that was that. Okay, so that was those. So basically, pipe. You know, I know about these. This one. This. Okay. I demystify that. Okay, cool. I was like, what the hell? Are there really that many like pipe things? No, there's not. I'm learning Bash. Well, I kind of have to now because I'm trying to replace Bash with my language. So, because I also want it to be kinda same but not as well. Like all the pipeline-y stuff should probably be very much like Bash, but then the programming part is gonna be like Zig, like a scripting language version of Zig, basically. So with the pipeline stuff and all that, like redirections, all those kinds of things, yes, it's gonna be like Bash. So I have to learn about that. But then when you have things like the cases, the whatever, where also, yeah, I'm gonna have like some kind of pattern matching. Not exactly sure how it's gonna be, but you know, in Bash you have like globs, you have I'm not sure if there's like regex for like directly in Bash, but I think I'm gonna try to have something. And if it's not gonna be regex, maybe it's gonna be you're gonna be able to execute some program or something here to integrate into the pattern matching. I'm not sure exactly, but I'm pretty sure I want to have some kind of pattern matching because I like to have that. And Zig doesn't have it, but Yeah, it's gonna be cool if we could get something in like that. So it's kind of like, you know, I'm taking Zig also and kind of like expanding it a little bit. Okay, so we did these ones. I'm not sure about this one actually now. But yeah, it could be used for like fallbacks, but again, you could just have a fallback here as well. So, and if you just want to handle an error, you don't really need the assignment part. You just need to handle the error and exit or whatever. So it's not crucial, but it could be cool to have. Okay. I mean, junior operators, we don't even have any junior operators actually. You know what? Do we even have booleans right now? I mean, we have booleans. We have like my boolean A is gonna be true. My boolean B is false. And then I guess we'll make a table. No. A and my boolean B I mean, let's just call this true and false. Don't need booleans here. Okay, so we do have it. Although it's... Now, I think what we could do is this. We store this in like booleans. And if we echo this out, nothing happens. Invalid string question. Oh, I think this is because of void. That's right. Okay, let's try and fix this. Actually, the blocks should become execution results. Yeah, they're voids. Let's do this right now. So what we do is we will the thing is, it depends on the context. That's the thing. It depends on the context. So like this is executing the binding, right? So we process the value, and it could be pipeline, process. The thing is, we don't really have one for blocks. Like, what would a block be? We don't have a process, which it very well could. It's kind of akin to a process a little bit. It's also kind of like a runic file where you have like declarations. It's kind of like a scope, actually. Instead of popping this frame, we could detach and return this as a value. As a scope, and then I think we could also always capture the things, because we need to kind of we need to capture the output and put it somewhere. Like if we're doing a binding, I guess if we have a scope, we have captured it, we could put it in an execution result with a scope, actually. So we don't need to have an execution result here. We could return a scope, and then that would be put into the execution result. Yeah. This could be put in here, which is a scope ref. if we got a scope, we could do something akin to whatever we're doing over here. We don't really deinitialize the value though. We just include it in the execution results. But we don't have a process though. The exit code would be, I guess, null for now. We'll have like a to-do. What about the exit code? Like, it could potentially be that whatever first process fails, that could be the exit code. I'm not sure. But we will capture the output and this we don't really need to do, although we could, I guess. But no, we don't need to do that. Okay. And then we set the scope to be scope. We move it in there, basically. Okay. So now we have a scope. If we execute the block, we're gonna get a scope execution result with a scope ref. So we could potentially also now, like, when we do a member access, we could potentially get to okay, well, that didn't go too well. Where's this deinitialize called? Okay, that's just the main deinitialize thing, I think. Okay. How is that? How is that a seg fault? I don't understand. Because this will kind of copy, or it will take those scopes that are currently like in the context, it will move them out and just return. Wait, what's happening here? So basically we create this ref here, which is a child. Okay, we will store all the popped frames in an array. We go through each level and we pop the frame node initialize, which we then put in this list. And then we iterate reverse to add them into a detached scope. Which we then return, right? So we're popping, like if you pop 3, you get them in reverse order, so we have to add them back in reverse order. There's probably some trick you can do with, like, I don't know, reverse. Well, there is a reverse iterator here, but yeah. Anyway. Well, what does reverse do actually? Does it reverse like in place? In place. Okay, but what kind of comparison are you doing? Swap. There's no comparison. What am I saying? It just reverses, right? So we could potentially just reverse this, but then we don't do whatever we're doing in here. Well, here we're just appending though, so okay, whatever. I'm not gonna change it right now. But anyway, that's detached. Now we're just detaching one, so it should just be a scope with this frame here, the single new frame here. With a bunch of potential declarations. And then that gets returned. And there's the value we get in, right? Like, I don't understand why we get a segfault. The only thing we're doing is we're detaching it, putting it in here, and then we forget about it. What we should get is like a memory leak or something. That's what I would expect now. Wait. No, yeah, that's the... Yeah, and then we return, we bind that. No, we don't return it, actually. We bind it. I am confused. Does detach not work? Like, we're popping the frame, so it should get popped from there. Okay, it might work. Maybe something weird is going on here. Oh, this is in another place. This is the for loop. Oh. Okay. And that returned, this returned. Where's the... We're evaluating that. We return everything. We forward the output. There's the output. Yeah, I think that was the last one because it was like 5 length. Okay. Okay, so it's maybe not there actually, but well, I guess it's the end of the for loop. Where is the end of the for loop? Don't we have for loop? Oh, this is logged. Okay, so it's there. For loop is done. Eval expression is done. We pop the frame. Yeah, for expression frame is popped. And then execute is popped, right. Execute is done, statement, run statement is done, and then we do a bunch of... Wait, this could just be that we're at the end, actually. Okay, yeah, we're at the end, right. Okay. So then a bunch of the initializing... What's happening here, actually? Log bindings. Those are all the scopes of the for loop, or 1, 2, 3, 4, 5, yeah? Yeah, it could still be, yeah, it could still be that, the initialize array element. So, yeah, so the for loop returns an array of scopes that are now detached, and apparently cannot be deinitialized properly, perhaps. So this scope stack is detached, yes. Okay. Scope stack. Deinitialize. Where are you? We set ourselves to undefined. After. No. Is it if this frame kind of references itself or something? Like if we destroy the scope ref? Okay, well let's just not do this then. There we go. That should solve the issue, right? No? Scope 5 4 2. Okay, stop doing that. Yeah, that's also, look at this. It should be this, right? If you want to do something like this. I'm just not gonna do it. Yeah, still errors. Closable. Oh. I see. Okay, I see. So, I think what's going on is when we evaluate the block, we do a bunch of run statements inside. Now, each of these will kind of execute the expressions inside. They will have their own context. For example, processes, which will get like no, actually the issue is actually wait. Yeah, this whole pipeline thing has gone through so many different things, so I have to kind of remind myself on where we are right now. But this would grab the pipeline and consume it. after each one, which makes sense though. We're in a block. And then deinitialize the value that we get. Which also makes sense. Like if we capture, let's say we capture the value, we should do it from outside. And that's what's happening in the binding. The binding should capture the thing. And then we should be good. But doing that apparently is an issue. Oh, is it because the pipes? No, wait. Because we don't have a pipe that will consume at this point. But we should have a result though. We should have like the buffers filled up, basically. See these buffers here, they're gonna put in this thing, and then we process the binding value. If it's a scope, we try to capture the output, and we try to forward the pipes. Maybe we don't need to forward the pipes. Actually, okay. Let's try that. Okay, I saw some issues maybe, or maybe not. Or yes. Double free, okay. Okay, but we do get these things now. Great. So that was what I wanted to have, because I want to store all this in a variable so that we can pipe it into a formatter program. But okay, let's see if we can fix these first. So let's check here. Maybe it's on this scope ref, it's already like initialized something, I don't know. No, it shouldn't be though. Okay, here's the allocation. So it's the pointer to the value inside the RC, which is created binding expression block detach. It's created here. All right, where's the first three? First three is happening RC deinitialize, value deinitialize, interpreter value, execution deinitialize. Yep. Callee deinitialize. Evaluate call expression. Okay. Call it literal expression call statement master. Okay, and here's the second free. Another call initialize. Same line of code. Man, the call stack is something else. We kind of need to extend this to see everything here. But that comes from directly here. Run script, execute run statement. So it's the outermost statement here. Call. Execute expression, evaluate expression, evaluate call. So it's an outer call thing. Evaluate literal, render string. So is it this one? Oh, or yeah. Okay. I think what's going on is when we clone this, we don't clone the ref. I think that's what's going on. Yeah. Yeah. Here we go. Inner equals clone get pointer. Alright, so if we have that, we will do inner standard, no, inner scope equals to scope ref clone. No. I guess we put options there. Still double free. Now here. First free, yeah. Wait. No, let's just ref. Don't ask me what the actual difference is right now. God damn it. Yeah, detach. Okay, this is from the scope to initialize, I think. Yeah. And then the first. No, this is the scope to initialize. Wait, it's the same. So where do they diverge? Did it main? Did it go? I mean, it could be that we just have two places of the same thing, and we forgot to ref or something. Or okay, we should use the initialize function of the ref. But this is just a scope stack. I see. Okay. Okay. Right. So I'm going to do, yeah, so now I recently also learned there is something called, maybe we have it, I'm not sure, column. Separator. So if you have like terminal records table. Okay, there's probably a whole bunch of stuff you can do with this, but I'm just trying to figure out the most basic example, I guess. Okay, here's some example here. So separators colon T, not sure what that means. Oh, table, right? Okay. So if we do like and table, let's remove that. Let's have like T for table and separator is that. How will that look? Oh. Okay, see? But then we get a segfault. God damn it. Okay, so we try to use a pipeline with why would that be an issue? Like, we already tried this. This all works. Is it because we had an interpolation here? Okay. Binding of lock with pipeline. Okay, that's a segfault. So if you have a block result, you have it in a pipeline and then you're using this result and add it in a pipeline. Like, this doesn't make any sense to me, but okay, let's try and figure it out. We got a segfault. We're trying to get the result of a closable. Oh. No, it still doesn't make sense, but okay. Okay, this is in the outermost thing. We're trying to execute this expression. We evaluate the thing. We should get a pipeline out. We will process the pipeline, we consume it. Where was the error actually happening? Process, it's in forward output. So we consume the pipeline. Which will forward it. And then we forward the output. We get these things, we forward them, and that's where things go wrong. the source is where things go wrong. So the source is possibly then still connected, but like now the source is like, okay, so we can have like a connection that's still lingering. So basically, like when we consume the pipeline, should we also disconnect at the end? Like we're forwarding there. Once they're closed, what happens if we disconnect now? We should just be able to disconnect each pipe. So there's no chance of this going wrong. Yeah, we'll just do this. There might be other issues now, but or maybe not. Maybe we have the exact same issue. Forward output, forward pipes. Okay, let's add, let's go to stream, enable logs, process, now trace writer. So we got standard out pipe. We're connecting a source from echo. Ended stream. So it should also record that it's actually closed as well. So that's the thing, is like it should say that it's closed the next time, even if we try to read from it. Maybe it's, oh, the hell. I'm not sure if this is an actual problem or not. Right now. Like this AAA is because Zig sets everything that's undefined. It sets to this address here, or it fills it with A's basically. Oh, it's the label. Well, okay. Now we get a different error. We get an error because we're trying to put the label out, but it's probably still the same issue. Just trying to figure out why this is happening. So this is happening here actually now. It's not even in the pipeline. Okay, let's just check. So let's say, well, we have a bunch of pipelines in here, or like processes at least, that echoes out stuff, right? They are all connected to the I think they're all connected to the actual standard out pipe. But then when it's done, we should... So the pipeline gets consumed, we disconnect. Okay, so we don't disconnect here though. We forward these pipes. Let's disconnect them as well. I guess we want to disconnect the source. I guess that's true for all of them actually. Let's just disconnect the source. Okay. Let's hope we still get the output. Okay, there we go. Now that works. Cool. So there's our tables. The AND table and the OR table. Cool. Awesome. I guess it didn't care about the new line here. And these are not really, well, okay. Let's do like AND table. And then the OR table. Okay. So true is true, false is true, false is false. No, wait, this is false. True, this should be true, false or true. There we go. Okay. All right, so we got the booleans. I mean, we could do the same in sh. Where are those? Above the arrays. Is this like almost exactly the same? Not really, because we don't have blocks. I guess potentially we could put it in a subshell, maybe. And pipe it directly. Well, so there are blocks. You can just have this. Ah, it's the syntax here. That's weird. Maybe. I don't know. Yeah, something weird is happening after this. Is it like this? I still have no idea how bash works, by the way. But the colors look better now. So there we go. Now, can we set something to this? Can we actually set like AND table equals this? Does that work? Can I quote it? I guess we could use here doc for this. Maybe. Does here doc work? It actually looks kind of nice. Cat. Does that work? Or table equals cat. No. Does this work? Okay, that sort of works. Okay, I have to do something like that. But then the values inside are not really shown. Okay, I have to look this up. True. Is it like true like this? No. What the hell, man? Oh, that's for tests, okay. So test is also like this, right? Oh, you have to have space. Okay, but it's, I guess it's like the same thing, maybe. I'm not sure. It doesn't output anything. How do you like stringify this? Bash echo true. prints false, prints 1. I mean, do I have to do this? Or what? What the hell, man? Return is the thing, right? I just think it's funny when you have like return, yeah, and then there's like a whole bunch of paragraphs in here. Calls a function or source script to exit will return when specified ends. Ends returns end. Okay, sure. So wait, if no, it's like this. If okay, so then you have true two of these. If bool then echo true, else echo false. Okay, so then here we have to say bool to string, and then I guess we have to do this again. No, now the colors are all messed up here. Is it because it's a string in here? I mean, it might be. Oh, I see. There we go. I just missed that. But that should work, right? Yeah. There has to be a better way to do this, but I just don't know. Uh, 68. What's the issue? Oh. No. Okay, there we go. Except it's all false. Okay. Or okay, I don't really understand how values work in Bash. Like if you have a literal false or true here, that should work here. Yeah, everything is true now. But if you pass a thing that says true, or true and true, I guess maybe it's because they are all... No, it's all false. What if you pass true like this? Okay, that's the only thing that's true. And then true and true. That will be like an error or something. No, it's not. But would this be this and this now? Not like... What if we had just a parenthesis? Okay, what if we do this? Still false. Still false. What the hell? Okay, bash Boolean algebra. What is happening? Okay. Boolean and operator. Okay, shell operators combine rest of the commands. Yes, shell sequence. Command also known as test. Just regular command is A and O for an operator. Can't use this because it's shell syntax. But wait, Bash has fancier test formats. Double things. If you use double square brackets, you get access to things like brackets and wildcards. You also use shell operators like this and freely inside the brackets because unlike this, the double bracket form is a special shell syntax. Oh man, I don't want to learn this. I don't want to have this in my brain. Can you put it here then? Does that work? It doesn't look like it's working. Do I have to do like this? still says false. I mean, it might be this. I have no idea, man. No. We have to do this. I don't know, man. No. What's the difference of this? What is this? You work. Okay. That works. That's unexpected, but I mean, I guess. Do you have to have space here? No, you don't. Okay. Do you have the space at the end? Yes. Okay, whatever. All right, there we go. Wait. Or we don't go, actually. We don't go anywhere. What the fuck? Hello, Mindfrex, what's up? What's up, what's up? Oh my god. I'm getting my brain wrecked here with this bash stuff, man. I don't want to learn this. I just want to make an equivalent script. Okay, so what I'm making right now, I can show you here. I'm making a language. So on the left hand side is my language that is kind of like, it's gonna work like a bash replacement script language. So it's gonna work kind of like bash, but with different syntax basically for the programming stuff. The pipeline stuff is basically gonna look the same, but for things like if, else, for loops, and basically everything else, it's gonna be, you know, it's gonna look like Zig, actually, like the Zig programming language that I'm building the language in as well. So you can call, you know, echo here. This actually doesn't work anymore, so yeah, print it here. Yeah, never mind that. Yeah, we can call whatever executable here, same as with bash, and you can have pipelines, and here's some if stuff, if true. I don't know what I'm doing with bash, so that's why it looks like this. But yeah, some inline ifs, for loops, etc. So basically, I'm trying to kind of make, I mean, to me, a sensible syntax with these strings, because I feel like bash is a nice language if you want, you just want to make something, you know, quick and dirty, some kind of script that calls a bunch of things and orchestrates some things together. It's really nice for that, for, you know, some quick and dirty, maybe command line interface or something. But then it's like I always struggle with the syntax. The syntax is so different every time you try to do something, and I don't want to have all that in my head. So every time I try to do something with bash, I always have to look up the most basic things. So now I had it, and I just, okay, let's just create my own language that works kind of the same but different. Yeah, so that's what we're doing here. And you can kind of see, compare the differences here. So I'm trying to keep, like, here's my version, here's like bash. Yeah, I mean, I get why some people kind of like it, because it feels like you're typing in these runes into your computer, and it does some cool hacky stuff. But it's like, I don't know, I don't want to learn the syntax, so I don't want to keep all that information in my head. And it's so cumbersome also to look up stuff as well. Like, even if you Google something and you get like a different source every time you Google something as well, and it's like you have to scroll down to get an answer, and you just want the answer to the most basic thing, like how do you test if a file exists, if a directory exists, or, you know, if this string equals that. Yeah, there's a repo. Let's see, I can send you a link. It's not really like ready or anything for use right now. I mean, it's still in like very early development here, and it's not really meant to be like a serious language either. It's more like a toy language for me to learn about making languages as well. So, you know, it's basically my first language that I've made to this degree, I would say. And yeah, there's a lot of things to still look for, but the pipelines do work. The pipelines work actually now, and they're streaming as well. So that is like one of the major things that I've been implementing, and yeah, that should work now. So yeah, I mean, basically now I could start use it right now. I should actually maybe even start trying to do that and let that govern my implementation here, because what I've been doing is basically I've been looking at this to-do document and adding more scope here. But really, if I start to actually try and use it for actual stuff, then I might find, okay, well, it would be nice to have this feature or this feature now, so let's start working on that, basically. But yeah, so something like this, like the pipeline or an and. Let's actually do that right now. I forgot what I was doing actually. Oh yeah, I was I did this Boolean stuff like the and and or table. And if we look at this, you can see this is kind of like, it's super slow by the way, but that's not the point right now. I could optimize it later, but basically, oh yeah, this outputs as 1 is 0, right? That's right. So 1 is true, 0 is false. So it's kind of like the other way around in Bash actually. Yeah. Yeah. I'm not super organized when it comes to commit messages. I mean, I usually say, when I say stuff, it's basically because I've been working on it for a long time and I never committed anything, and then I commit and I don't really care to go and look at all the changes I made or make like 100 commits. I just want the stuff in and continue working. Don't really care. Just look at the code changes. Yeah, I was doing these, and then I was like, okay, let's do the bash equivalent. So this is how it works here. You can, this is Runic, so, which is the name of the language, by the way. So I have these Boolean tables, like and or table. So what I did was, you can actually assign a value to a block of code like this. So this is a block of code here, or a block, essentially. It's just like its own scope. And then you can start to echo stuff in this block, which will then end up in this variable here. It won't be outputted to the screen or to the terminal directly. It will be bound to this variable here. And then we can echo it out and also pipe now then into something else. So we can pipe it into, for example, this column program here, which I guess exists in many places. So this would turn this into a table with -t, and the separator is a pipe thing here. So it would take all this and put it in this thing, and table, and then we can pipe it. So that's how I solved this issue. And then I tried to do the same thing in Bash, and it kind of, you know, I did work now with here docs, which I'm not sure if I'm even gonna have. I'm not sure, but here's like you have. I did it like this. So and table equal. I had to test this a little bit. Holy shit! What happened there? Okay, I had to like screw around with this a little bit, but now we can set and table equals, and then this kind of expression. I'm not sure if this is good or bad. And then you can't, and then there's like a here doc. Here docs, I mean, it's kind of nice when you have like a multi-line string like this. I actually kind of like it, but I'm not sure if I'm gonna have it. But yeah, and then it's basically the same thing. However, then the issue comes to these things. Like, I'm still trying to figure out how to actually format those. I know what, let's do, let's just do this. Does that work? Oh. No, wait, it has to, yeah, no. Oops. I don't know, man. You will, well, you have to install Zig 0.15.1. I usually use a version manager called ZVM. One second. This one, you can install 0.15.1. And then you just zig build. Or zig build, and then the output is stored in zig out bin runic. And I'm not sure what the state is of the repo right now, but you might get it to work. And then you just type, you just type like, runic and then my runic file.rm. There's no like standard in or repo or anything like that yet. '66. Oh, it's that one. Okay. Oh, so it's trying to it's trying to. Well, I have no idea, man. Okay, there we go. Right, but it's like the other way around, because 0 means success. Maybe I should have it like that, though. I mean, it makes sense, because we're trying to interface with these ish programs. So actually, this should actually be 0 and it should be 1. That just so goes against my logic so much, but yeah, it makes sense in this context. Yeah, see? 0, 1, 1, 0, 0, 1. Okay. Now instead of doing like this, we could do pull to string. Okay, so you have to practice these things sometimes. There we go. All right. Wait. Oh. It's kind of weird. Why does or work like that? Okay. Is or a program or? Okay, anyway. Yeah, double quote. Let's just get rid of all these goddamn things. Always true. Well, I want it to be always true, so that's the thing. What if we did this? That's also always true. Instead of this true, just use true. Okay. Ah, I see. If true. Okay. Yeah, that's a lot nicer. You don't need to put it anywhere. You just need to run it. You can run it anywhere. Yeah, it's up to you. It doesn't need to be stored anywhere special. It just needs to be executed. Declare and assign, separate avoid, masking, return. Okay. Useless echo. Well, it's kind of to show the, it's just to show the thing. So declare and assign separately. Can I hide this message? Instead of command echo foo, just use command foo. You mean this? What if I add like a space? Oh, I see. Well, what if I use printf? Do you care then? Oh yeah. Okay, now you don't care. Good. Yeah. MVP RN. Let's see. Let's do check MVP. This is an example string. What the hell? So now bash doesn't output this. Also, this is read-only, so what? Is that why we don't see anything? There's no error Well, what if we do like error, like we do this? Ah, there we go. Read-only variable, right? So what the hell? It told that the linter or whatever told me, the LSP here, declare and assign separately. But it's a read-only variable. Shell check. S2 Okay, cool. And by the way, it's super slow right now. So if you're thinking that your computer is slow or something when you're trying to run some, I mean, I'm not sure about the speed of, like, if you're spawning some process that chugs along, that shouldn't, the speed of that shouldn't be affected, but the speed of, like, between commands, that is very slow right now. Alright, cool. I'm glad that you think that. We've had some bash people in here. Well, I'm not sure if I'm, but knowledgeable in bash people in here. And well, no one has really said anything about this, that if it's better than bash or not. But you know, it's not really about being better. It's more about being like approachable for other people, like for people who are more used to, you know, a programming language syntax. It might be faster in C++. What do you mean? Faster in what? What is faster and in what way? Okay, cool. So in every way. Okay. I mean, it's not really comparable. It's like comparing apples to oranges, and it will not be faster. Or are you talking about Zig? Because that I might agree. Maybe. Who knows? But yeah, this is, you know, this is supposed to be a scripting language, of course. So it's not really, it's not supposed to be a compiled or anything, you know. All right, now like I'm not gonna write a compiler in Runic for Runic unless I actually make it into a compiled language, but that's not probably not gonna happen. Right now it's interpreted, so that is part of the reason why it's so slow as well. Okay. Oh yeah, so these ones, I want to be able to do those things. And they are basically binary things. Let's see if we have these in the tokens. So we should have something called, I don't know, ampersand ampersand, pipe pipe, there we go. Okay, let's go to AST and we have these binaries somewhere, hopefully. Pipe apply member assign. So let's add this in pipes. So this would be like, I mean, I guess this would be and or. This is where the two worlds collide a little bit. Because in Zig, the and operator is like the actual word and. While in Bash, it's ampersand ampersand. And both are kind of equally correct here. However, I would argue that we should use the Bash version because of how the pipelines work. It's like you're using them with pipelines. It should probably be keeping that syntax. Anything kind of touching pipelines, I guess we are trying to keep that syntax going. So I think even though I did add these keywords in, maybe you can mix and match. Maybe make it a hybrid. Use an interpreter for testing, compiler, building. I hate it when I have to recompile projects for like 10 hours. Right. Well, I mean, yeah. I mean, I think kind of Python has that as well. Like you can use it interpreted, but then you can also kind of build it into some kind of, I think it's some weird bytecode thing. So maybe because I've been starting to experiment with an IR just today, but I still need to work out like exactly how that's gonna work. But yeah, that could be kind of cool. Like because I want to have it for like debugging purposes and potentially in the future compilation as well. And maybe it will be more optimized in that form. I'm not sure, but we'll see. And maybe there's like optimizations to be made or something. I don't know. Python apps are shipped by just interpreter and source code into one archive. It just runs them both together when the archive is run. I see. Because I've seen the like Python, like, you know, if you get a Python based program, sometimes you get these files that are not Python code. They are some kind of bytecode or something that Python uses for some reason. Yeah, I don't know. Okay, so interesting. So they ship with a whole interpreter. How big is that? Okay. Anyway, do we have the pipe somewhere? I think we do have these in the Lexer. Let's just double check here. Yeah, amp, pipe. Yeah. And then now they're basically equivalent to and or, so we should already have that. Okay. Now we just need to make them work with pipelines. So basically, if we have a binary, yeah, I think the precedence is already done. 10 pipe is 50. Yeah, so this is way less here, and then or is even less. Or is like the least. Yeah, or is like where you have like the failure handlers. It's like Electron is slightly better. It only takes up dry space, no memory CPU. Okay. Yeah, I mean, this is very like this is very like toy language right now. Like it's basically gonna be for my personal use first and foremost, like to replace Bash with some like with this language instead. And I don't even need to focus on speed right now either. So it's like I might optimize it like when I get the chance in the future, and it's really becoming a problem. Like right now, it's like, yeah, it's slow. It's like I can see the lines coming in, and then you compare it with Bash, which is like, which I compared was like 10 times faster. I mean, it's not even comparable. Like Bash just instantly done. This Runic is like every line takes a while to get to churn through. But yeah, anyway, I basically done no optimization. It's like the opposite. I'm doing the opposite of optimization right now. But anyway, let's see. Switch must what possible? What? Are these? Okay, so we already had those, so I'm gonna remove that. And we're just gonna change this. I mean, logical. I mean, okay. It's kind of implying that we're working with booleans, which we kind of are, to be honest. But we're working mostly with like the exit codes, actually. Like, not really exit codes, but more, well, yeah. Anyway. Okay. So AST. Yeah, parser. Wait, no, the parser doesn't care. Not the parser, it's the evaluator now, because we should be having the thing. Let's add another thing here. So this should be like and or. So let's have something that will succeed, I guess. This will succeed and this succeeded. Okay, and then we try to run this. This won't work. Is that already? Unexpected token? What? Oh, right. We do need to add these here. Pipe. Alright, there we go. Now we get script execution error instead. Unsupported binary expression. So, you know what? When we get an error, are we showing? Yeah, we're showing the line of code, but we're not really showing the thing there. So when we do, what would this be? Run statement and something goes wrong. Or even maybe here. If something bubbles up all the way here, we render the error, which just prints the line of code and everything. So we could show the actual lines of code here. The thing is, those convenient functions are actually in here. This. So what language are you working with normally? Wait, what's happening? Why are we... Yeah. Why are we not seeing this? Oh, logo is not enabled, right? Actually, yeah, we have the span log. Rust. Okay. All right. Well, the problem is we don't have logging enabled. I guess we could just set it to be enabled. So good. There we go. Okay. Now we kind of see a little bit more of the issue there. So now, because it's a scripting language, so it makes sense to show the lines of code that went wrong, right? Like if there's a script execution error. Maybe. I don't know. All right. Look at all these copied code. Okay. How long have you been dealing with Rust? Or programming in Rust? What are we trying to do? We're trying to add the support for pipeline operators. So we have like pipe somewhere here. Well, we do have and. Yeah, here's the and ors. But we only have 4 booleans right now. So let's add. So this could be, I guess this could either be actually, what is this? How does this work? We have to consume the pipeline first. So we should actually get a pipeline here. We could get a pipeline. The right hand side doesn't actually matter at that point. The right hand side is just the left hand side. Few months. Won't code anything else ever again. Code Rust 24/7. I easily do this else. Okay. All right. I mean, you're kind of like me, except I'm using Zig instead. So if the left is a pipeline, we want to consume it. yeah, and then we get an exit code. There we go. Maybe. So what happens if we don't get an exit code? If we don't get an exit code, if we could get an exit code, that means we have a bunch of processes. If we don't get one, it means, well, that's not supposed to happen right now. We can only pipe processes right now. So I guess we should always have it. Not right now. If exit code is null. Actually, let's do or else. So okay, could you explain like what is so okay? Well, first of all, what language did you come from before Rust, or what languages? So now we have the pipeline, right? Well, it's consumed anyways. And then we're looking at the exit code. So if exit code is success, then we, well, actually we don't evaluate the right expression here. If the left is a boolean, we have to do it. No, actually, if the left is a boolean, no, if it's an and, we should always evaluate the right one. No, actually no, because if the left is false, we don't. If this is false, we will return boolean false. Otherwise, we return, now we return boolean, well, actually we just return right evaluate expression. Binary right. There we go. My first language that was Luau. Oh, Lua. And then, or is that another spin-off or something? Then I learned C#, and then Java, C, C++, Go, and now Rust. Okay. That's a lot of procedural OOP-like languages. It is a spin-off. Oh, okay. I was like, is that a typo or? Okay, Roblox. Okay, okay. I see. I see. Okay, so now if left is false, this is false. Otherwise, we evaluate the right side. There we go. And now it's kind of like, okay, well, if the semantics doesn't catch us with both sides has to be Boolean, then this would potentially could be any type. But yeah. But if the left-hand side is a pipeline, we will look at the exit code and we would we just return the right-hand side here. Okay. But otherwise, we don't. I think we just return the exit code at that point. Maybe. Could also return the pipeline, but that has been consumed. Also the value we deinitialize. Yeah, that's fine. Do you even need to be deinitialized? No, you're just an exit code literal, so that's fine. Alright. Cool. So that is the end. We could also have a process, which is kind of the same thing, except we don't need to consume it. The pipeline, what we do is we say scopes get term signal, get child exit code from this. But the problem is it might not actually be done, because we're not waiting for it. We just get the process and I get the result, but it might not actually be done. So this could be like an optional. If it's null, I guess we could wait for it, because we need to wait for it now. Now this waits for all of the processes. We just need to wait for one. We could also do this. We could do wait child which will give us the thing. I guess the process couldn't be. I guess the process could. It should be there now, but okay. Now we actually do. We call wait here. Well, it could have been waited already. So I'm gonna do if either we have the result or else we are actually going to do process wait, and then we will do so now this is an error, and we do try, and we do from term. There we go. And so now this is wait. But it still gives us an optional. It should be there though. Okay, I'm just gonna say it's there. Why are you unknown? We're clearly try. No? There we go. Or not. What the hell? Oh. There we go. Now we get it. Okay. So we wait for the thing. We will. Well, if we wait, we also need to forward the output actually. So let's do that. I'm pretty sure, unless that's already done. Well, I guess we'll find out. Okay, and then it's just the same thing here. Like if the thing is correct, or what is this? Oh, it needs to be a value. Right? Okay, so that's the and. Let's just see if it works. Okay. That were way too easy. So let's see if this fails. We'll do the classic JQ with some, give a bunch of garbage. Okay, so we see that it did not actually do this one. So that is correct. Okay, now let's do the OR. Also, okay, we need to test the pipeline as well. So let's just do like cat here. Actually, let's do two separate ones. Cat. Okay, I'm just gonna say print AST. So we have a pipe, we have a logical and left is pipeline, right is call. Right, okay, cool. That is good, so there's nothing weird going on with that. Script execution, unsupported binary expression. What is the unsupported? This whole thing, which is the and. No, that should be supported. That's a pipeline. What the hell? I need to go to sleep here soon. It's kind of late. Yeah, I probably need to go now. It's like 1:30 where I'm at. I just wanted to. I need to. Well, I want to figure it out, but. Oh, it might go in here actually. We didn't get an exit code, maybe. But we should get an exit code though. Okay. I'll do like to do. Find out why we get unsupported binary expression from Alright, but that's gonna be it for this one. Rating someone? Usually no. I mean, I don't see the point when we have just like 2 viewers or something. I usually don't. I usually only raid once we've been raided and there's like a couple of people in here. But I can raid. Trinary. I don't know what you're talking about. Also, thank you, Mindforex, for the follow. Trinary. Trinary. Ah. But that's 2 operators, right? Or it's 2 binary operations. It's ternary, yeah, I guess. Yeah, I'm not gonna send you anywhere. Go to sleep. Alright, see you later. Have a nice whatever. Bye bye.